Okay, so this week, this next one, I guess this is the second one for the week. Our topic is going to be strings. You've probably been using these since day one of your introduction to computer logic class. I've seen quite a few things about them, so not a whole lot of talking beforehand. This is going to be almost all examples. The technical version you've probably heard a couple times. A string is an array of characters. Very technical definition with the stuff we looked at in the previous video. All the things about lists, well, really, strings are immutable, so I might as well make that note here. Immutable. I think this was the last thing in the notes I prepared. The strings are immutable, so it's really like a tuple from what we looked at the other day, which that means to change. So if we want to change what's in a string, we actually have to make a slightly altered copy. And again, it's more a long-term thing, but that can have effects efficiency-wise. At this point, yeah, just make the changes, and the computer's going to make a copy with those changes in it. But more long-term, when you have to start worrying about efficiencies, you're not going to get much from strings, but it is something there, right? So we have our string. I'll just call it S in the picture here. Pointing at the block of bits over in RAM holding that data. But if we want to change it, what we have to do is make a copy of it that is slightly different. Hopefully that red shows up. I'll do that for indicate slightly different. And then refer to that copy instead. So a subtle thing, and strings are pretty efficient. We're talking about ASCII code or really anymore. It's Unicode, and just Unicode bits going straight through. So it's a very efficient thing anyway. We're not going to buy back much efficiency with this in most cases. Right? I can't really say what your software is going to be doing. Maybe your software needs to process the entire works of O. Henry. Somebody gave me a copy of that a couple of Christmases back. And, for an author that only wrote short stories and only had a decade-long career, that book is like that thick. I mean, it's a 3,000-page book. If you're dealing with that, then you're going to have some, then you're going to buy back a lot of efficiency. But in most cases, it's just a little bit. But at other times when we get to that point, which, again, is further down the road for y'all, sometimes any little bits help, right? If we can buy back just a few bits, it helps to add up to something eventually. So some technical things. What I like to say to describe strings is that's our written language. So basically just kind of written language, the way humans have stored data traditionally. But you can see on my notes here that it's only 3 pages long, and they're not even all for the talking parts, so this is almost all examples today. What are a couple key points? So I guess the key point is use double quotes to mark strings. So double quotes are the ones that always work. Some languages the single and double quotes are interchangeable. Double quotes are interchangeable. So Python's one of those. Like Python and PowerShell. Might as well add that to the list. We looked at it. So in both Python, PowerShell, and a number of other languages, our single and double quotation marks are interchangeable. We can use either one depending on what it is. Often, single quotes indicate single characters. As you move forward into other languages, the standard is single quote marks represent a single character, and double quote marks represent a whole string of characters. But in Python, whereas this semester, they're interchangeable. Quite a few languages, they're interchangeable, but it's not always interchangeable, so be aware of that. Python also has triple quotes. Might as well put that down here. Triple double quotes. In Python. Oh, okay. Hardly reach. That's supposed to say Python over there at the end. Kind of stretching. So triple double quotes in Python give us a multi-line string. Which essentially just makes the code look nicer. Code looks nicer. If we use 3 double quotes in Python, the interpreter just ignores any line breaks. Makes it look a little nicer. It's up to you which way you want to use that. Yeah, a couple more things I want to put on the board here, but I need to erase it, so I'm going to step out of the way in case you want to pause that, get those notes. But the main thing is single and double quotes aren't always interchangeable. And then our technical definition, it's an array of characters. So all our array stuff will work for it. And from what we looked at in the previous video, it's like a tuple. It's immutable. So all the stuff we looked at about tuples, and the book has about tuples, I guess, kind of referred to the book in that last video. That's that same stuff applies to strings. So let me erase the board and get the last couple notes up here. Okay, the last little bit of talking here. This first one, we haven't really talked about objects yet, but it's important for what we're getting ready to do with all these examples. Strings are objects. That's kind of important because of this concept. One of the core concepts of object-oriented programming is called encapsulation. So I'll go ahead and write that. All behavior and object. So all the behaviors an object needs are encapsulated. That doesn't look like an E, and that one's supposed to be a D. Sorry about the messy handwriting. So all behaviors and object needs are encapsulated. That's one of the core concepts of object-oriented programming, and it's kind of applicable to today's examples, so we'll go ahead and look at that. And that basically just means included or built in. So every behavior we want from a string is already included in a string. So that's what we're going to look at with the examples today. Another main point I want to make, I mentioned, I often refer to it as just written language. I'm going to go ahead and assume that by college level you're familiar with written language. So this point, and this one is very critical. I'll write it in a bunch of capital letters. Yeah, I'll add a couple more words in here. Never, ever, ever have a computer output a grammatical error. That one is absolutely critical. Never, ever, ever program a computer to output a grammatical error. That will make your code look buggy quicker than having lots of bugs in the code. Users will notice that one, so always be careful with the outputs. Double check them, triple check them. That's one of the concepts the programming essays I always define is meant to help cover that. Getting used to proofreading things before outputting them. But that one is critical. If users see grammatical errors coming from the program, they're probably going to give up on that software really quick. They're going to assume it's not good software right off the bat and go to something else. So that one is, never program a computer to output a grammatical error. So check those thoroughly. That's kind of an important one. And then I guess the last thing I'm going to put on the board here we're going to take a look at the examples at regular expressions. I don't think the book has them in it. I should have double checked before starting here. I read a lot of textbooks for classes, picking textbooks and then using textbooks, and so I've seen a lot. But I think our textbook here does not include regular expressions. Basically, what it is I'll write this out: string encoding information about patterns. Search through string. So regular expressions are an encoding scheme, and we pass them in as a string, and it's a string that encodes information about patterns. So various patterns that we could search for, like things that are not letters. Our escape sequences are included. Look for line breaks or tabs. Different patterns that we could have in in a string that we can search for and manipulate based off patterns rather than looking for a particular case, right? We can encode information about a pattern and look for, and hopefully that'll make more sense when we see it, kind of introduce it here. You'll see it more in later classes. Regular expressions are a very, very useful thing, and yeah, when we see it in examples, hopefully it'll make more sense. But that's kind of the talking for this. We've worked with strings before. They should be fairly straightforward. It's written language. This key point, keep that in mind, please. Always double check your outputs. Make sure everything's grammatically correct, because that will make your program look buggy quicker than having a lot of bugs in the program. So keep that one in mind, and otherwise it's storing our data and working with our data in written language. So most of it should come straightforward. Let's go over here and work through examples for today. Okay, so today is pretty much all examples, and not even really that many of them. So this video will probably be kind of short. Get idle started here. So I guess to start off with a note about our weekly notation. And well, as I'll point this out, we were just talking about the triple double quotes. So double quote, double quote, double quote starts a multi-line string, which I often use. It's fairly common to use as multi-line comments. It's not really a comment. It's not ignored. Just garbage collection grabs it immediately. It is a string, but it allows for spreading the string out over several lines, and the interpreter just ignores any line breaks. So it can make the code look a little cleaner doing it that way. But our weekly notation this week is all caps notation. At least 3 words. At least 3 words long, all caps notation, and this has kind of become the standard to represent constants in the code. So you'll see this one a lot. Fairly straightforward. Capital letters use underscores to separate words. And I think I'll do this one in methods, and then we'll just call them from the shell. That seems the easiest way to put a bunch of them together in a file and kind of organize it. So we need to define a method here, and I'm going to call this first one loop through string. Because as we talked about, a string is an array of characters, which for us here in Python, really I guess we should be saying is a tuple of characters. It's a collection of characters that are immutable. We can't change them. Best we can do is make a copy that's slightly different. Well, we need some string to check when we do this, so I'll set up a parameter passed in string. Seems like a good name. And, well, I'll go ahead and say it's a tuple in Python. So we can just, it's like a tuple, so that stuff we saw in the previous video still applies. So we can walk through it in a for loop. So for, some sort of reference, each single character, that worked out nicely, 3 words, fits our naming convention to 3 words and kind of describes it. So for each single character in passed in string, I want to do something. I don't know, I'm just making something up here. I'll do it if block. So if each single character is equal to the letter R, we're going to look at them one at a time. If it's an R, we need to print something. Oh, I don't know, just some sentence here. I'm a pirate. Yeah, have it say that. I'm a pirate. R. Something to indicate that it found the letter R. Otherwise, print, I don't know, don't see any R. I guess violates that thing I said just a moment ago about not outputting grammatical errors. That's not a very good sentence. Don't see any R. Yeah, I just made that point, so I should probably put something grammatically correct there. No R here. Still not a very grammatically correct, but better than the first one. So if it sees the letter R, it loops through whatever string we pass in, it's going to print this out. And if there's no R's, it's going to say no R here. Go ahead and save this. So we have down here. Example files. And what can I call this? String example. That'll work. So save it and then run it, and it's an array, a list, some sort of collection. With what we've seen, it kind of goes best to call it a tuple. But whichever term we want to use. So we created this method. We didn't have anything happening here. But from over here in the shell, once that's started, it knows about that method, so we can ask for that. What did I call it? Loop through string. Loop through string, and then pass in some sort of string to test with it. Here is a string to test this with. So you can see it went through one character at a time. There's H, no R here. E, no R here. Then the I'm a pirate R. So it's kind of, we can go through it one character at a time. That filled up quickly. But on a more probably commonly used one related to that is some of those other methods we saw in the previous video will still apply. One that's going to show up a lot is the length. Count characters in string. Method that name. I'll call the parameter the same thing again. Passed in string. So we're going to pass the string in, and we can just return that length function we saw with list and tuples. So the length of passed in string. So if we run that, count characters in string, a test string for this method. It tells us there's 29 characters. And if we count these, let me do a shorter one. Count characters in string, string. So six characters. And notice the length is 6, but if we went to index them, we'd still have that 0 thing. So S is a 0. Our last one is index 5, but length 6. We'll probably do this other one. This is going to relate. So we can do substrings the same way. And there are other methods to pull a substring out. I'm just going to talk about this one for the example because doing it this way works in any language because a string is always an array of characters. So if we treat it like an array, we can always, it'll work no matter what language we're in. A string parameter. That fits the naming convention. Probably use that one a few times here. And so you can probably tell from the name the 3rd to 5th character. So I want to go from the third character in a string to the fifth character and return that. So a string parameter, and just like we saw in the previous section, we can specify indexes by square brackets, and then in Python, a colon represents 5. So index 2 is our third thing, and index 4 would be our fifth thing. This goes up to, but does not include the last one. I'll put a note here. Includes first, but not second. So kind of that ask for the beginning, count at the end. So that up to, we're not going to the end of this 2 index. We're going to the beginning of this 2 index. So the fifth index 5 is not going to be included. Let's run that real quick. I forgot what I called it. Third to fifth. Third to fifth. Something to test with. You can see our third character, 1, 2, 3 when we count it, or 0, 1, 2 when we index it, is going to be the M. So there's our third, fourth, and fifth character. So it goes up to the bits where this T starts. So up to, but not including the second one. But that's kind of like what we saw with stuff we saw with list and tuples. And that works in any language, because those 3 things will work in any language, because a string is always an array of characters. So I'm going to put a comment in here. Strings are always arrays. These work in any language. So, yeah, at that point, I'll say it again. Strings, no matter what language we're working in, a string is always an array of characters. So this sort of thing will work in any language. Another thing that's true in all languages, strings are objects. Are true in any object-oriented language. I guess not all languages are object-oriented. But if we're in an object-oriented language, strings are objects. This means any behavior we want from a string is already encapsulated, which is included or built in. So it's ready to be used. So the rest of the things we're going to look at here have to do with object-oriented. I should make another note here. This syntax is particular to each language. So obviously we're going to look at the Python syntax for this. Hit that thing again. I don't like to work at the top or bottom of a screen. White space for scrolling. So we're going to look at Python syntax, but the same methods will be available in other languages. It's just going to be slightly different syntax. What's a good one to start with? I guess I'll start with this one. I've found I use this a lot. Okay, character index. Maybe we want to know where a particular character is at, or in particular, the next place it occurs. Well, this method we're going to look at gives the first place it occurs, but we can read up to that first place, and once we have that, then we can start there and look for the next one. The next one is something that shows up a lot. So this method tells where the first place a certain character shows up is. So a string parameter and then the character to index. Did I spell that correctly? C-H-A-I. Okay. Before I had to lean forward because the R's and A's look kind of blended together there on the screen. So we're going to pass in some string, and we want to know where a certain character is, like where's the first place an E shows up. And I guess we can just return this. I'll do one and then the other. So a string parameter, and then this is the object part. It's object oriented. So to access the behaviors built into an object, we use the dot operator. So a string object has this built-in method called index. And in most languages, it's index of. In Python, it's just index. And then we pass in what character do we want to get the index of. Character to index. I'll do this and then there's a second thing to put in here as well. We'll come back and do that. So if we run this, call that method get character index and a string to search through. So we're going to look through this random string here, a string to search through, and well, like I just said a second ago, let's look for the letter E. So it tells us an E shows up at index 13. Right? So 0, 1, 2, I'll do it this way, holding shift. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. There it is, index 13. So that returns the index we could ask for to get an E. And what you'll often do with this method is once you know it's there, then you'll note that and then start searching again, starting at 13, and eventually go all the way through the string. That's where I find use that one a whole lot. Another one that's in Python, I'll just do it as a second return, which is definitely going to run out of the room on the screen here. So remember we have that the backslash, which just tells the interpreter to continue to the next line. Since we ran out of room, the instruction continues on the next line. I'll do that to make it look a little neater. And we also have Are index in Python, which is the right index, and this gives the last place it shows up. Character to index. I'll add a comment about that. Index gives first, Are index or right index gives last. So this should return both values, and there's a point we couldn't quite make earlier when we saw multiple returns, so this seems like a good place to make that too. So if we ask for that again, get character index, a string to, I'll use the same one, whoops, where'd my cursor go? To search through. This time let's look for the letter T. So the 3 here, that's the first index where it shows up. So 0, 1, 2, 3. And the last time it shows up is at index 19. Out counting back, we can see is that one. So index gives us the first one, Our index gives us the last one. And another point we couldn't make earlier when talking about multiple returns is notice what our return type is when we said to return 2 things. we get back a tuple. Should recognize that now. It's in parentheses, so that means we have an immutable collection of things that were returned. That may be important somewhere down the line when you do multiple returns. They are immutable, so make sure you assign them to something immediately if you're going to want to change them. And I'm just kind of going down these in the list that seems like the most often to get used. So, well, as I thought about it, it seems like a couple of these get used most often. Finding where something is and changing the case. So uppercase, lowercase. And we need a string to pass in, so some random string. I'll call our parameters at this time. And I'll just return it. So return some random string, and maybe we want that all lowercase, which this is exceptionally useful for making comparisons. If you're going to compare user input to maybe you ask the user to enter either yes or no. And there's a lot of ways we could type yes, right? We could put yes, yes, yes for reasonable ones, but we could also do stuff like this, right? Y-E-S, Y, and all sorts of different combinations. And we don't want to write a whole bunch of orders, right? We don't want to check that in an if statement. So if the user gives us this, or the user gives us this, or user input equals this, or user input equals this, it's a whole lot easier just to maybe make that all lowercase and check them all at once. And again, to do that, it's encapsulated. It's a behavior we would want from a string, so it's encapsulated in the string object. So to get to it, we need the dot operator. And in Python, it's just lower. And we don't need to send any arguments because we're just going to take whatever the string is and make it all lowercase. Might as well go ahead and return the second one to the other one. Random string, then dot upper. It should be obvious. That's the same thing, just uppercase instead of lowercase. So Control S, and then F5. And we can call that method change string case. Here is a random string to test this with. Let's get some uppercase and lowercase letters going there. And you can see, get an all lowercase version and all uppercase version. So that is exceptionally useful if you're going to check user input, because there's no telling how the user is going to spell the word, right? If we ask the user to enter yes or no, there's a lot of variety they could give us on yes or no. So, but if we change it to all lowercase, then we can at least check and make sure they gave YES in some fashion. Same thing with uppercase. Okay, had to do some editing there. That's where that other little piece of the window went. So we're going to do another method here, and this is one we want to do a lot. The name should make sense. We want to check if something's a number. Maybe before, when we have things in a string, we want to make sure, like on input, we want to make sure that what the user gave us is a number before we cast it to an integer and do math with it and all that. So we need a parameter to check, so hopefully a number. So we're going to pass in something, some string. We want to see if it's a number or not before we do casting. there's kind of a warning coming along with this. We're going to look at a few things. So let's start with the one the book shows. Hopefully a number dot is, or this is highly abbreviated, one of the older functions in Python. So is all numeric is what that stands for. Abbreviating the word all kind of has always struck me as a little odd, but is all numeric. And we're going to check this string and see if it's, and then either return true or false, depending on if we have a number or not. So save that and run that. So calling that method, check if number, and we'll pass in some string, maybe 74 to start with. Yep, 74 is a number, so that worked. Check if number. Oh, let's try some random string. Oh, false, that's not a number, so that fits our expectations. This next one is kind of where some warnings might need to come in. 3.14. We look at that and we know that's a number, but Python tells us it's not. And that's the thing. So this, come back over here, this only checks a number. And actually we have some others. So I'm going to split this up between lines again. So remember, backslash just tells the interpreter, continue on the next line. Make the code look a lot nicer without having to go way over to the right. Scroll way over. Let's try a different one. So hopefully a number. We also have this method in Python called isDecimal. I'll put a few in here. Hopefully a number. We also have isDigit. This is a great example of how there's lots and lots of ways to do things in a programming language. Hopefully a number that is numeric. There's a few of them there. So let's see if any of these will work for a floating point number. We Control S to save it, F5 to run it. Whoops. Must have spelled something wrong there. Hopefully. Oh, I forgot commas. Notice the error happened here, but the problem was up here. Just another note on checking those. It's a list of things to return, so I need commas between each one. I just put the backslash in there. So Control S, F5. So check if number. We'll try the same thing again. 74. That's a number. Yep, return true on everything. Check if number. What did I do the second time? Some random string. Turn false on everything. Check if number 3.14. It should be a number, but we're getting false, 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 false. Python's telling us that's not a number. And I've thought this very, very strange for many years. We don't have a built-in way to check for floating point numbers in Python. We have to manually make some adjustments. I'm going to delete this in a second. Oh, it just popped in my mind. That'll be a great example when we get to regular expressions. When we get to regular expressions, we can look for patterns. Like we can check to see if we have a digit or any number of digits. If we have digits, one decimal point, and then more digits. That'll be a good example when we get to floating to the regular expression stuff. What I've typically done is a try exception block. So I'll have some sort of variable result equals, I'll just start it at false, whoops, in Python, and then do a try catch block, try except block. So try and cast it into a floating point number. And if it can be casted into a floating point number, then that variable is going to be true. And if it can't, we'll set that variable to false. That's what I've typically done. It's quick and easy. That'll make a good example for irregular expressions. When we get there, we can check to see if we have digits, any number of digits, one decimal point, one dot, one period, whatever we want to call that symbol, and then any number of digits. But we have to do some sort of manual workaround if we want to check for a floating point number. I'll just leave this in here. This is how I've always check for floating point. Python only checks for integers with built-in methods. I'm going to comment this out. It doesn't necessarily pertain to what we're doing today. That's what I've always done to check. And then afterwards, we can just check that result variable. It'll change the name of that. Is float. Then we can just do if is float. And if it's true, the if block will run. If it's not, if it's false, the if block won't run. But we have to, the point is we have to manually check. We'll look at that in regular expressions here in a few minutes.